Welcome to section 3 of the course, which is on EC2. In this section, we will learn an introduction to EC2, what it is, the instance types available, the storage, as well as an introduction to the AWS CLI, how to create EC2 instances by launching, connecting, and how we can monitor them. We're going to continue from the IAM section by using roles with EC2. We're going to learn about EC2 metadata, what it's useful for, and how we can access it, as well as user data by showing a Python installation on EC2, what the Elastic Load Balancer is, or ELB, and how we can maintain user sessions, as well as a quick summary with key takeaways and a quiz at the end. Welcome to video 3.1. Introduction to EC2, Instance Types, and the EC2 CLI. We will cover in this video a quick introduction to EC2, what the EC2 instance types are, the EC2 pricing plans, the EBS introduction and types, and an introduction to the AWS CLI. What is EC2? Amazon Elastic Compute Cloud, or Amazon EC2, is a web service that provides secure, resizable compute capacity in the cloud. Think about it as a VM or a virtual machine in the cloud. It is designed to make web-scale cloud computing easier for developers. Let's cover some benefits of EC2. First of all, there is elasticity. You can increase and decrease capacity in minutes. You don't have to wait for a server to be provisioned to you for hours or days or even months as you would in an on-premise environment. You have complete control over your instance, you have root access, you can install whatever software you want. There are no restrictions from that point of view. Hosting flexibility, you can decide which instance types you want, how many CPUs you need, what kind of OS you want to install, memory and storage. You pay only for what you use. We will discuss pricing plans a bit later in this section. It's integrated with most AWS services, for example, S3, RDS, DynamoDB. You can just communicate with most of the AWS services using EC2. What are the types of EC2? We will be discussing a few types of EC2 instances. First of all, we will start with the T2 family. It is designed for general purpose. This one we will be using extensively throughout the course, mainly because it is part of the free tier account, and also that we have burstable performance, which means that basically we accumulate credits when we're not using the T2 instance to its full capacity. And if we need to burst for a bit of time, for example, there is a certain demand that has increased in the last few minutes or seconds, then the T2 can burst and handle that amount of requests for you. Some example cases include dev environments, websites, web applications. Then there is the N4 family, which is general purpose and is used for small and mid-sized databases, data processing tasks that require additional memory. Think about app servers. C4 is compute optimized. It's mostly for applications and databases with high CPU requirements. And a few other examples include web servers, batch processing, distributed analytics, video encoding, high-performance front-end fleets. Then we have R4, which is memory optimized. This is for apps and DBs with high memory requirements. Some more examples include high-performance databases, data mining and analysis, in-memory databases, applications performing real-time processing of unstructured big data. Then we have X1, which is again a memory optimized type of family. It's large-scale enterprise class in-memory applications, for example, SAP, HANA, Apache, and Presto. Then we have P2. which are accelerated computing instances. Those are mainly general purpose GPU compute applications. They include use cases such as machine learning, high performance databases, molecular modeling, seismic analysis, computational finance. Then there is the Gen2 family type, which is another accelerated computing instance. Think about it for graphic intensive applications, 3D application streaming, video encoding, as well as other server-side graphic workloads. Then there is F1, another accelerated computing instance. Think about FPGAs, and these include use cases for genomics research, financial analytics, real-time video processing. This is mostly how you would be using hardware to accelerate your code. Then we are moving on to storage optimized instances, which include i3, which can be used for NoSQL databases like Cassandra, MongoDB, Redis, in-memory databases, also to scale out transactional databases, data warehousing, as well as Elasticsearch. And then there is the D2, which is storage optimized and dense storage, mostly for massively parallel processing, data warehousing, MapReduce and Hadoop, distributed computing, distributed file systems, network file systems, and log or data processing applications. Going into the exam, you don't really need to remember all of these together, but I think as a solutions architect or a certified developer, you will need to understand them in real life. You will have to understand a bit more about which ones are for general purpose, which ones are compute optimized, which ones are memory optimized, storage optimized or accelerated computing instances. But you don't really need to go very in-depth in these particular exams. What are the EC2 pricing plans? At the moment there are 4 different pricing plans. The first one is on-demand, spot, reserved, or dedicated hosts. We will start by talking about the on-demand price plan. This is a pay-by-the-hour price plan. This is applicable to when you don't want to commit long-term or you don't want to make upfront payments, mostly for short-term, spiky, or unpredictable workloads that cannot be interrupted. Think about using on-demands when you're developing applications or you're testing them. And we won't be using on-demand EC2 instance types for the rest of this course, just because we don't want to make any payments for any other types of instances. Plus, these are covered by our free tier. Then we can talk about spot instances, which you can bid on spare EC2 computing instances up to 90% on-demand price. When you request spot instances, you specify the maximum spot price you are willing to pay. Your spot instance is launched when the spot price is lower than the price you have specified, and will continue to run until you choose to terminate it, or the market spot price exceeds the maximum price you have specified. You think about using spot instances when you have applications that can have flexible start and end times, applications that are only feasible at very low compute prices, and users that have urgent computing needs for large amounts of additional capacity. You can also include a duration request for spot instances, and if you include a duration requirement with your spot instances request, your instance will continue to run until you choose to terminate it, or until the specified duration has ended. Your instance will not be terminated due to changes in the spot price. So even if the market spot price moves up and your bidding price is not valid anymore, your instance will not be stopped if you have specified that duration parameter. A few things to remember that are very important. If AWS terminates your spot instance, you will not be charged for that particular hour. If you yourself go and terminate your spot instance, you will be charged for the full hour. And just one thing that AWS do for you before they terminate your instance is they give you a 2-minute notification before your instance gets terminated. Next, let's move to the reserved pricing plan. This gives you a significant discount of up to 75% compared to on-demand. It's a 1 to 3 year term. 1 or 3 year term. Think about using this with applications with a steady state or applications with predictable usage. Anything that you can know for sure that in the next year I'm just going to need this capacity, or I'm going to reserve this amount of capacity for the next 3 years because I only expect this particular steady state. And it's going to work out cheaper in the long run. A dedicated host is a physical EC2 server for you solely. It helps you meet compliance requirements when multi-tenant virtualization is now permitted. Furthermore, dedicated hosts allow you to place your instances on a specific physical server, and you can consistently deploy your instances to the same physical server over and over again. And it also lets you use your existing server-bound software. For example, licenses such as Windows Server or SQL Server. Now let's move on to EBS. What is EBS, or Elastic Block Store? It provides persistent block and network-attached storage volumes for EC2. Think about that one EBS is part of just one availability zone and is automatically replicated. So an EBS volume will be part of a specific availability zone, and each EBS volume will be automatically replicated within its availability zone to protect against component failures. Typical use cases include file servers, running your own database, data warehousing. Think about big data analytics engines like the Hadoop HDFS ecosystem and Amazon EMR clusters, relational and NoSQL databases like Microsoft SQL Server and MySQL or Cassandra or MongoDB. Think about stream and log processing applications such as Kafka and data warehousing applications like Teradata. Now, let's talk about the EBS volume types. We'll start by talking about solid-state drives or SSDs. The first type of SSD is General Purpose SSD or GP2. It balances both price and performance. It is recommended for most workloads. What we need to remember is that you get 3 IOPS per gigabyte, up to 10,000 IOPS. It can burst up to 3,000 IOPS if you have less than 1 terabyte of storage. And a few examples that can be included for general purpose SSD are boot volumes, dev and test environments, virtual desktops. Then we can move on to provisioned IOPS or IO1. This gives you the highest performance for SSDs. Think about using these in latency sensitive apps or mission critical apps. They can handle large database workloads such as MongoDB, Cassandra, MySQL, PostgreSQL, and Oracle. This is when you need somewhere from over 10,000 up to a maximum of 20,000 input-output operations per second. And just use them for IO-intensive relational NoSQL databases, as I have mentioned before. Then we can move to HDD, or think about them as physical disks. The first one that we're going to talk about is Throughput Optimized, or ST1. This is a low-cost HDD option. Use this for frequently accessed throughput-intensive applications. For example, data warehouses, big data, or log processing. Mainly anything that has to do with sequential data, like MapReduce, Kafka, and ETL workloads. And this cannot be a boot volume, and we will be discussing a bit more in detail in the next lecture when we're going to go hands-on. Then we have Cold HDD or SC1, which is The lowest cost HDD is for less frequently accessed workloads, and use this for data that requires fewer scans per day, for example, something like an SFTP server, and this one cannot be a boot volume either. Then we're going to talk about magnetic. This one is part of the previous generation of EBS volumes, but the exam can still cover it. So you think about using this for infrequently accessed small data sets, and when performance consistency doesn't matter too much. As the last topic of this lecture, we will be covering the AWS command line interface, which we can find at aws.amazon.com/CLI. The AWS command line interface, or the CLI, allows you to control multiple AWS services from the command line and to automate their usage through scripts. The AWS command line interface can be used with Windows or Mac and Linux computers. I'm currently using a Mac environment and I will be following this particular step, but you can run the installer for the 64-bit or a 32-bit Windows if you're running Windows. What the AWS command line interface is going to allow you to do is mainly do API calls to your environment in much easier than if you have to go via the console and click on all the buttons to get the functionality that you want. So we can now move to my terminal and I can show you how we can set it up. Because I'm going to be working in a separate environment from my normal Python installation, because I want to keep this course and everything else that I have on my computer separate, I will be creating a virtual environment. You can follow me if you want to, but if not, you can just install the AWS CLI directly within your Python version as a library. So what I'm going to do is I've created EC2 directory, which is currently empty. I will be creating a virtual env to host my CLI. So I'm just going to go and create a new virtual env, and I'm just going to call it env. It's going to be created in just a short amount of time. And now I'm going to go within it, source, environment, bin, and activate. I'm using bin bash, so this is the activation that I will be using, the console that I will be using to activate my environment. And now I'm just going to pip install AWS CLI, which was the step that AWS recommended. Now it is almost going to be done, and then we can configure our environment. So what I can do next is go AWS configure, and now I'm going to get an access key ID and that I've already entered. What you can do is go back to your IAM user. You remember that in the IAM section when we went hands-on, we created an IAM user. In my case it was Raluca, that had SDK that has a secret access key and an access key ID that we downloaded the credentials for, and then I showed you in an Excel sheet. You just have to copy the AWS access key ID for yourself and then enter your secret access key ID as well as the default region name, which for me is EU West 1. You can use whichever other region is closest to you. You can leave it blank, but I believe it's better to be able to connect directly to your default region rather than having to enter it as a separate parameter to the API calls that you're going to make in the future. So I'm just going to leave the default output format to none. So I've entered my AWS access key ID, my AWS secret access key, the default region name, and the default output format, and then I can just enter. And what I'm going to do next is going to be AWS help to see, oh, we can actually see what the manual page just look like and what the options are. Or I can do AWS EC2 describe instances. So I know how many instances I have currently. Because we haven't created any instances on the account, there are currently no instances to be described, there are no instances to be shown, but this is the first stepping stone that we have taken to actually go and interact with the AWS environment via a CLI. Via the AWS CLI, we will be building up in the next lectures when we will be going hands-on both within the console and then within the terminal.